Energy metabolism governs everything. That was not an exaggeration, everything. Last year, around this time, I wrote an article on my Substack, What I'm Doing for Allergies, which included an extensive protocol based on biochemical reasoning and some randomized controlled trials, which reduced my allergies by 80 to 90%. This year, I'm not doing anything for allergies. Why? Because the spike of tree pollen that usually drives the onset of my seasonal allergies occurred by complete coincidence 2 days before I started phase 2 of my biochemical optimization, wherein I added riboflavin to my biotin supplementation. For those 2 days, my allergies came with their usual onslaught. I did not want to change my diet or supplements in any way, as that would interfere with the interpretation of my highly controlled experiments. So I simply dealt with it by rinsing my nose with a neti pot, washing my eyes in warm water, taking a shower, and changing my clothes every single time I came in from the outdoors. And then I added riboflavin. Boom, gone. The allergies just disappeared 2 days after they arrived. Before we get going, I just want to let you know that I have a free gift for you. That is my MTHFR protocol, a 7-page quick guide to optimizing and personalizing your methylation status using foods and supplements. My MTHFR protocol is free to anyone who subscribes to my Substack, whether free or paid. Use chrismasterjohnphd.com/MTHFR or use the first link in the description. Enter your email, click subscribe, and you will immediately get a welcome email in your inbox that contains my MTHFR protocol as a downloadable PDF. I hope you find your free gift useful and enjoy it. Once again, that's chrismasterjohnphd.com/MTHFR. I was not adding riboflavin to help my allergies. I was adding it to treat a rare genetic defect that I am heterozygous for that causes a riboflavin-responsive respiratory chain disorder. I'm going to be writing about my experience with high-dose biotin in phase 1 soon, after I finish analyzing all my data. I will write up my experience with riboflavin in phase 2 once I'm finished with phase 2, and I'm currently about a month into it. So after this initial disappearance of my allergies, like magic, I found that they weren't completely gone. So I spent hours hiking in a Pennsylvania forest during the peak of tree pollen season. And by the time I had spent a couple hours, made it about a mile into the forest, which, wouldn't have taken a couple hours, except that there were a lot of beautiful waterfalls to stop and look at for a while and things like that. By the time I got through it, I found that my allergies were picking up to minor symptoms, maybe on a scale of 1 to 10, where 10 was the worst it was last year, probably 1.5 or 2. Then I found after I got back to the city, I had residual minor allergies in the week following, but now I currently spend hours a day outside in the city. It's still peak tree pollen season. This time last year, I would have, before I started my allergy program, terrible allergies. And after I started my allergy program, minor allergies. And I'm basically allergy free. Sometimes I sniffle here and there, maybe once a day I sneeze, but I don't use a neti pot. I don't change my clothes, and I don't take a shower just because I was outside. I'm not taking any supplements for my allergies. I'm not even taking creatine, which I would otherwise be taking just for building muscle and strength, if nothing else. But specifically because I have frozen my diet and supplements to exactly what they were last summer at the time that I made some discoveries in my lab work that I've written about and talked about on podcast and video before that led me to my current metabolic experiments with biochemical optimization. And so just to be completely controlled, I'm not even taking things that I know would help my allergies that I would otherwise be taking for general health anyway. And I still am simply allergy free. despite the fact that I'm really pushing my boundaries in terms of deliberately spending lots of time out in the pollen that I'm most allergic to. Okay. So fixing my energy metabolism has proven to be radically more effective and radically simpler in its eradication of my allergies than focusing on treating the allergies themselves. Why? Because energy metabolism governs everything, and allergies are no exception. So what I'm giving you now was originally published in written form, and I will link to the written form on Substack in the description. And you should head over there if you either prefer to read or simply want access to all of the links that I'm going to be referencing. Okay, so in the May live Q&A, and this is the MasterPass Q&A, MasterPass members get access to a monthly Q&A. We discussed how a problem in the respiratory chain, the mitochondrial respiratory chain, where energy metabolism occurs, could cause autoimmunity. So in this particular case, low ATP compromised the absorption and distribution of minerals, including zinc, and compromised the oxidation of NADH to NAD+. This person also has a genetic impairment in the zinc-dependent enzyme acetaldehyde dehydrogenase, which is responsible for the second step in vitamin A activation. This results in a triple hit against vitamin A activation, one genetic, one from zinc deficiency, and one from a high ratio of NADH to NAD+. And this results from this triple hit in low retinoic acid levels, regardless of the supply of vitamin A. Improving the supply of vitamin A can help, but it can't fully repair the situation, and it eventually leads to vitamin A toxicity symptoms, even simultaneously alongside deficiency symptoms from an accumulation of retinol esters alongside low retinoic acid. And because retinoic acid prevents autoimmunity, the energy metabolism impairment causes an autoimmune condition. The autoimmune condition is simply one of the symptoms of vitamin A deficiency that is, again, not driven primarily by a low supply of vitamin A. It's driven by low activation from this triple hit on energy metabolism and the funneling of the energy metabolism problem into the activation of vitamin A based on the non-energy related genetics. Okay, so it's not necessary to be able to map out the exact biochemical details of how any particular impairment in energy metabolism manifests in any particular clinical condition. And this is because energy contains primacy over everything. And this is true because of the laws of physics, which trump every other particularity of biology. There are no laws in biology, but all biology is based on the laws of physics. So the simplest way to view this is as follows. 1. The cellular utilization of energy dictates whether things go wrong or right and how wrong or right they go. 2. All other genetic and environmental factors, including nutrients, toxins, stress, come together to dictate what in particular goes wrong or right. As an analogy, you might want to think about this as the operating system versus the apps. Energy metabolism is the operating system. Every app runs on the operating system. You can have an app that goes wrong for other reasons. Maybe the file is corrupt, or maybe the app wasn't made very well, or whatever. But if the underlying operating system is dysfunction, none of your apps are going to work. But if you have a little bit of a dysfunction in the operating system, it might make apps that don't work it might impact the apps in a way where it's not that nothing works. It's just that everything's going a little bit wrong. And in that case, the apps that are the worst are going to go the worst. All right. So the analogy isn't perfect, but I think it's helpful to the extent that we think about everything, every specific system, such as your central nervous system, your peripheral nervous system, your urinary system, your skeletal system, your muscular system. All of these things are all operating on the base of your energy metabolism. And so you can have genetics or nutrient deficiencies or a certain amount of stress or whatever that will fundamentally make one of those systems the weakest for you, or maybe make a particular error be more likely in one of those systems in you. But whether your energy metabolism is working well enough will dictate whether those things actually do go wrong and how wrong they go, versus can you overcome whatever problems you might have in that area and make everything work well because energy metabolism is fueling all the systems well enough to overcome any underlying predispositions to problems that they might have. So as a general rule, this means that the most root cause actionable item from among several actionable items will always be one that impacts energy metabolism, and this should always take the primacy of action. However, there are two exceptions. So one is an outright emergency. So for example, if you have a screwdriver stuck in your eye, the most important priority is to take it out as safely and painlessly as possible. Nevertheless, if you have a 10% impairment in your rate of energy production, you will be slightly more likely to get a screwdriver stuck in your eye as a result of impaired neuromuscular coordination. And even with otherwise good nutrition, you will have a slower rate of healing that will increase the risk of scar tissue formation. Thus, even in the emergency, energy metabolism is not the imminent problem to solve at the height of the emergency, but it is extremely relevant. The other is a chronic condition caused by a dramatic impairment in a particular biological process that is dramatically more severe than any impairment in energy metabolism. To take an example of this, let's use a complete penetrance version of a cystic fibrosis gene. Most cystic fibrosis genes have an average penetrance of 71.3%. Meaning almost 30% of the people who have the genes do not develop the disease. However, some extremely rare versions of this already rare disease have apparent 100% penetrance, meaning everyone who has that particular gene does get the disease. Now, my guess is that with a larger sample, the penetrance would be less than 100%, but let's just take this at face value. So what's going on causally and mechanistically in this disease? Cystic fibrosis is a defect in an ATP-dependent transporter. What does that mean, ATP-dependent? That means even if it functions normally, that transporter requires magnesium ATP, that is energy produced in the mitochondrial respiratory chain, in order to function. Cystic fibrosis is a defect in the function of that transporter that leads to clinical effects as a result of excessively thick mucus. Now, the main endogenous defense against excessively thick mucus is glutathione, which is synthesized using energy in the form of magnesium ATP, and which is recycled using energy derived from glucose in the pentose phosphate pathway. So if you have compromised production of ATP, you will make that transporter function worse, even if you don't have cystic fibrosis genes. And if you have cystic fibrosis genes that only cause cystic fibrosis in 70% of people because of the other variables going on in their body, then certainly those people are way more likely to get the disease if they have a marginal decrement in their ability to produce ATP. On top of that, reduced production of ATP will reduce your ability to synthesize glutathione, which will, for completely independent reasons, determine how well you are able to thin the mucus. And so this is another thing that would compound on top of any genetic predisposition to cystic fibrosis. So for someone with a average penetrance, 71.3% penetrant cystic fibrosis gene, their supply of ATP and the activity of their pentose phosphate pathway, because of its role in recycling glutathione, is very likely to modify their risk. For someone with an extremely rare complete penetrance gene, their ability to decrease their risk by working on energy metabolism will be far lower. However, I don't trust the complete effects of any gene ever, since I learned of a child with an inexorably lethal holocarboxylase synthetase mutation who is kept alive with 1.2 grams of biotin per day, which I described in my article When High Dose Biotin is Truly Needed. Now, you could point out that if those impacted by the normal 31.3% prevalent cystic fibrosis genes had a genetic or nutritional impairment in glutathione synthesis, this would also modify their disease risk. And this is consistent with the fact that oral or inhaled glutathione provides some modest benefit to cystic fibrosis patients. But my point is that if there's a defect in energy metabolism, this will compromise the synthesis and recycling of glutathione, as well as the function of the specific transporter whose impairment is the single cause of the disease, and will exert greater influence than a more specific impairment in glutathione synthesis. In most non-emergency cases, someone is likely to have some impairment in their energy metabolism, since healthy energy metabolism requires all of the B vitamins, all of the electrolytes, iron, copper, and sulfur, and is impaired by diabetes, hypothyroidism, hypoadrenalism, and is impaired by hundreds of different genetic defects that are each rare on their own, but for which carrier status, which typically confers 50% of the biochemical defect, is collectively common. I would argue that in nearly all of those cases, more will be gained from fixing energy metabolism than from working on the specific thing gone wrong, and in nearly all cases, energy metabolism should be worked on first. The reason this principle is so universal is because of the laws of physics. So the laws of thermodynamics. There's 4 principal laws of thermodynamics, and we are mostly concerned with the second one. These are the 4. The zeroth law of thermodynamics essentially states that all heat is fungible. That is, all heat has the same quantitative characteristics and is fully interchangeable. This makes the math discussed and all the other laws make sense. The first law of thermodynamics essentially restates the law of conservation of energy in thermodynamic terms, and it just simply implies energy can be transformed, but it can be neither created nor destroyed. The second law of thermodynamics states that any closed system will, over time, reach the maximum state of entry possible for a given amount of internal energy, and that only an input of energy can reverse the tendency towards entropy. Some chemists resist this conceptualization of entropy, but entropy can most intuitively be described as disorder. And in order to understand it intuitively this way and also have it be rather accurate, I think it's best to think about it as the random mixing of things according to their probability distributions. From this, we can conclude that there is a universal imperative towards greater and greater disorder, and the only defense against this disorder is energy. The third law of thermodynamics states that the entropy of a system approaches zero as its temperature approaches absolute zero. There's basically extremely limited application of the first law, massive application of the second law, and really no particular application of the other 2 laws to human health. So here's the extremely limited application of the first law. Since humans would be long, and the reason that the other 2 are, it's not that the other 2 are irrelevant. They exist and therefore they're relevant. But the zeroth law is basically just enabling the math of the other laws. And the third law, we would be long dead before we approached absolute zero. So it's not relevant in the context where we're alive. So the first law is basically limited to being a justification for the CECO truism, the calories in, calories out truism. That is, calories in must equal calories out if you are to remain weight stable, after discounting the weight attributable to water and other things containing low amounts of energy or types of energy that are not usable by biochemical pathways. So for example, water has energy, but we don't break it apart to harvest the energy in a biochemical pathway. And after accounting for the different mass to energy ratios of fat mass versus different types of lean mass. This has relatively little utility except to act as a check against magical thinking. So for example, if you went keto and lived off fat bombs that exceeded the amount of energy that you burned or lost in your urine, and you got fat, the first law of thermodynamics and its implied psychotruism would allow you to make sense of this and to modify your diet to lose weight by avoiding the magical thinking that if you go keto, you lose weight no matter how many calories you take in versus how many you burn. So in short, there's very little health utility to the first law. That's the extent of it. By contrast, the second law has universal primacy over everything. The second law of thermodynamics is the ultimate arbiter of everything that happens in the universe. The universe is a closed system, and the first law states that its energy remains constant. So the second law implies that its entropy is always increasing towards its maximal state. If the first law were not true, the second law would not mean that entropy must always increase, because the universe could increase its energy as a defense against the entropy. However, the first law is true, so the second law holds that because there is no increase of energy to be found, the entropy of the universe always increases until it reaches its maximum. However, a human being is a system connected to her surroundings, where the sum of the human being and her surroundings equals the universe. The human can decrease her entropy so long as she, one, takes in new energy, and two, increases the entropy of her surroundings. This allows the universe to comply with the second law of thermodynamics. In broad strokes, we do this by one, eating food, which takes in new energy, and by two, evolving heat into the atmosphere, which increases the entropy of our surroundings, because heat is the most disordered form of energy. Thus, we irrigate energy unto ourselves and we deload entropy into the atmosphere. We then use energy to do the work of creating order around us, making civilizations in our own image, where we make low entropy societies that release even more heat into the atmosphere. All life and health are most centrally defined by being high energy, low entropy states. When you lose maximum energy and obtain maximum entropy, you die. When you lose only a little bit of energy and obtain a little bit of entropy, you get somewhere between less healthy and sick. As explained in lesson 1 of my energy metabolism class, Thermodynamics, Energy, and Order, this is why a 150-pound human will eat 2,000 pounds of food in a year. We're constantly offloading heat to make the entropy of our surroundings increase more than the order we create within our body so that we comply with the second law of thermodynamics. So what does a high entropy human look like? Entropy is statistical disorder, random mixing of things along their probability distributions. What would your face look like if it were higher in entropy? Your ears would not be in a position that's best suited for hearing. They might be anywhere, such as on your cheeks or inside your eyes. Your mouth would not necessarily be connected to your throat. It might be on top of your head or beneath your chin, and so on. Thankfully, resistance to change is also a feature of everything in the universe, and this is quantified by the activation energy imposed on any given change. This is described in lesson 2 of my energy metabolism course, Activation Energy and Enzymes. That activation energy can be supplied by, for example, abrupt force delivered to the face. Indeed, blunt trauma could move our facial features around in undesirable ways. However, we would be long dead if we suffered sufficient trauma to arrange our face into a truly random probability distribution. However, let us consider some random mixing that we are more likely to witness in the real world. A high energy, I shouldn't say in the real world, in a living human being. A high energy, low entropy state is one where we can win a race or powerlifting competition while awake and sleep well at night. A low energy, high entropy state mixes these two things together, and we are wired and tired. A high energy, low entropy state is one where our immune system attacks pathogens, removes things that don't belong, and leaves alone that which should be left alone. A low energy, high entropy state mixes these things together, and we get sick often, we have allergies, we have autoimmune disease, and we fail to clear cancerous tissue. A high energy, low entropy state allows us to maximally contract our muscles when contraction is needed and fully relax our muscles when it is not. A low energy, high entropy state mixes these things together and results in fatigue or muscle tension or the rigidity, tremors, and slow movements of Parkinsonism. A high energy, low entropy state allows us to build lean tissue and avoid excess fat. A low energy, high entropy state mixes these things together and makes us skinny fat. If the only thing going wrong were a decrease in cellular energy, we would see every conceivable problem manifesting equally. But that is never the case. Even in someone who's homozygous for a specific severe defect in mitochondrial energy metabolism, their clinical presentation will look unique as a result of the many variations in their other genes, in their nutritional status, in their exposure to toxins, and in the stresses and traumas that they have experienced. Far more often than that, we have a unique mix of many of these problems alongside a unique mix of many assets. In the balance of those, we may wind up rather sick or amazingly healthy. But whatever, but what is what but what remains relatively constant across people will be that a strategy based on optimizing energy metabolism will have the highest probability of moving the needle in whichever way one wishes to move it. For example, someone who took home silver may happen to be heterozygous for a defect in pyruvate dehydrogenase deficiency and may have intuitively gone keto to help take home the silver. In that case, high dose thiamin might help that person take home the gold. This hypothetical person was never high entropy, but becoming lower entropy by optimizing energy metabolism allowed them to take home the gold instead of only the silver. Someone with genetic, nutritional, or lifestyle factors that predispose them to a high rate of clotting is going to tend towards a high clotting state, not a random mix of high clotting versus low clotting. Nevertheless, a high energy, low entropy state would allow them to protect most of their tissues against the higher rate of clotting and divert that characteristic into a higher rate of wound healing. A low energy, high entropy state would put that person at greater risk of pathological thromboses. For example, deep vein thrombosis, or for example, the clotting that plays a role in ischemic heart disease. Someone with genetic, nutritional, or lifestyle factors that predispose them to cancer will be most at risk for whatever cancer they are predisposed to. A low energy, high entropy state will not make them randomly spotted with often benign, sometimes malignant tumors all over their body, nor will it make their hair, their muscles, their tumors all equally likely to grow. But it will make their cells less universally differentiate into the proper cell type, which thus makes them more likely to become cancerous. And it will make their immune system less discriminatory against cancerous tissue and thus less likely to remove it. So the low energy, high entropy state in combination with the predisposition drives the predisposition toward the specific cancer state to become active. It's not necessary to map out all the mechanistic details of all of these. It's simply the case that there are no biological laws, that all biological processes are epiphenomena of the laws of physics, and that because of the second law of thermodynamics, the random mixing of chemicals and biochemicals will lead to the random mixing of the epiphenomena that those chemicals and biochemicals generate. I gave above the specific example of how a respiratory chain disorder could lead to autoimmunity. This is a result of NADH and NAD plus randomly mixing and ATP and ADP randomly mixing. That is, the second law of thermodynamics holds that in the absence of an energy input, NADH and NAD plus must become randomly distributed amongst themselves, and ATP and ADP must become randomly distributed amongst themselves. In a state of life and health, you maintain vast differentials towards high ATP, low ADP, high NAD plus, low NADH, and so on. So this random mixing of these biochemicals at the base creates two relevant secondary phenomena built on top of them. Zinc becomes randomly distributed. It is randomly distributed instead of concentrated inside the human versus outside the human, and within the human, randomly distributed versus delivered to the correct enzyme. And the forms of vitamin A, retinol, retinal, and retinoic acid become randomly distributed amongst themselves rather than forming a directional activation of the vitamin A that favors retinoic acid. These secondary phenomena lead to tertiary phenomena built on top of them. Low retinoic acid compromises the differentiation of immune cells. Rather than becoming the cells that are most beneficial to have, they become a more random mix of cells. And this takes away the rhythmic rise and fall of myeloid-derived suppressor cells during infection and takes away the normal suppression of Th17 cells under all conditions. And these tertiary phenomena then lead to a quaternary phenomena built on top of all of this, which is that the immune system fails to heavily discriminate against that which is a pathogen to be killed versus that which are things that should be removed versus those things that should be tolerated and left alone or even built up as being important parts of the host. And in the chaos that ensues, you get autoimmunity. So, although it's by analogy in a way that may irritate someone directly in the fields of chemistry or physics to say that the second law of thermodynamics leads to random mixing of immunity against three different things, it actually is the case that will happen as a result of increased entropy in ways that you can literally describe that would satisfy a chemist, at the bottom, when you talk about redox partners reaching chemical equilibrium, and then that spills over to the random mixing of all the epiphenomena that are built on top of it, and you get to autoimmunity. And this is much the way that you would get random mixing of secondary colors if you were to randomly mix the pixels of primary colors. So, for example, if you had a square of material and in a highly ordered state, you had blue over here and yellow over here and red over here. If you start getting a more random distribution, the primary colors are going to mix into the secondary colors, and the secondary colors are going to mix together, and you're actually going to have a lot of brown from all of them mixing together, and so on. And so it's much in the same way that when you have the things at the base, the biochemicals reaching chemical equilibrium as a result of increased entropy, all of the health properties that are built on top of the constant pouring of energy into maintaining very distinct properties that are very far away from chemical equilibrium, all of those things fall because they're built on a house of cards. So it's always going to be the case that random mixing of the underlying principles leads to random mixing of the epiphenomena. And while it's not the case that all order is desirable, it is the case that all health and life is a form of order, and that decreasing order and increasing random mixing is always going to be contrary to health and life. Thus, there will always be a way to trace low energy and high entropy at the most basic chemical level to a state of dysfunction, but the particular path this tracing takes will be shaped by the unique synergy of the person's genetics, nutrition, lifestyle, exposure to toxins, and stresses. So how do you optimize energy metabolism? Energy metabolism has several components: the neurological and hormonal regulation of it, the biochemical infrastructure of it, and the idiosyncratic genetic impairments in it. The neurological and hormonal regulation of energy distribution. Long-term abundance is signaled by leptin. Short-term abundance is signaled by insulin. Some stress by cortisol and adrenaline, other stress by inflammatory signals. The brain makes a calculation of how much energy is at hand and what the imminent and predictable future demands on that energy are, and decides how much energy can be spent. It makes your energy budget. This emphasizes the importance of healthy body composition and healthy stress management. On top of that, copper, vitamin C, zinc, tyrosine, and glycine, and iodine are all important nutrients that form components of this neurohormonal control. The biochemical infrastructure of energy metabolism includes the protein, carbohydrate, and fat that we burn for energy, and the micronutrients that are cofactors in energy metabolism, and the proteins and other compounds that we synthesize to make energy metabolism happen. The micronutrients most closely involved in energy metabolism are all the B vitamins, all the electrolytes, that's sodium, potassium, calcium, magnesium, and phosphate, iron, copper, and sulfur, and antioxidant nutrients, which include protein, vitamin C, vitamin E, zinc, copper, selenium, and iron, and manganese, are needed to protect the biochemical infrastructure of energy metabolism from harm. Then there are many toxins, too innumerable to mention, that can cause acquired impairments in any of that infrastructure. Idiosyncratic genetic impairments in energy metabolism that are rare as individual diagnosable diseases are likely to be common as heterozygous partial biochemical impairments. My suspicion is that it is very common to have one or a few carrier status mutations that do not lead to a disease, but do form idiosyncratic bottlenecks in energy metabolism. I believe that healthy body composition, stress management, together with adequate micronutrients, are likely to take care of the lion's share of diabetes, thyroid disorders, and adrenal disorders. However, I also believe that diabetes is an epiphenomenon of heterogeneously disordered energy metabolism, where there are common contributions such as overweight and obesity, and perhaps dysfunctional aspects of our environment like pollution, indoor living, artificial lighting, and so on. But if I'm right about the idiosyncratic genetic impairments in energy metabolism, this is the missing link that makes diabetes or overweight more difficult to solve than can be done easily with the low-hanging fruit of good health in many people. For example, I've already shown you data in my self-experiments in the biochemically unoptimized state that chronic use of dextrose powder lowers my fasting glucose. Improved fasting glucose on a higher carb diet appears to happen to a lot of people, but it's the opposite of what happens to the group means in randomized controlled trials. I will show you data in the next two installments of my self-experiments that high-dose biotin on its own without supplemental riboflavin can send me into the pre-diabetic range for fasting glucose, which is contrary to the randomized controlled trials of high-dose biotin for diabetes that I analyzed when high-dose biotin is truly needed, which aren't unanimous but generally support biotin being good for blood sugar management. I will also offer you a seamlessly coherent mechanistic explanation in my next installments of exactly why this happens as a result of my heterozygous mutations in biotin recycling, biotin activation of enzymes, and the riboflavin responsive enzyme ACAD9 that is responsible both for fatty acid oxidation and the construction of at least one or two of the mitochondrial respiratory chain complexes. In the past, I've produced the low-hanging fruit of weight loss, link in the description, that cover easy things people can do to lose weight. Those don't work. More data-intensive calorie management, if necessary, can be used to optimize body composition. Spiritual traditions, gratitude journaling, using your imagination for sufficient hope instead of excessive worry, meditation, nature walks, healthy breathing, good sleep-related practices, healthy social and familial relationships, proper schedule management, and being honest about what you're capable of handling to yourself and others are all good ways to manage stress. Of course, nutrition and idiosyncratic impairments in energy metabolism can make everything above easier or harder. When I write about phase 2 of my biochemical optimization, I'll describe how riboflavin, presumably by treating my heterozygous ACAD9 deficiency, spontaneously rewired my brain from a negative outlook to a positive outlook. For managing micronutrients, I have the Vitamins and Minerals 101 free class, premium features for MasterPass members, the Vitamins and Minerals 101 Cliff Notes, which are all the major practical points about micronutrients that I've learned over my career for what used to be less than a cup of coffee when they were first released, and currently less than what a nice tip to a barista would be with inflation. And then Testing Nutritional Status, the ultimate cheat sheet, is my complete system for using signs, symptoms, dietary analysis, and lab work to manage micronutrient status. The best comprehensive screening for nutritional testing is as follows. A Genova Ion plus 40 panel, which you can get from True Health Labs. Vibrant America micronutrient panel, which you can also get from True Health Labs. And from LabCorp request the following: a complete blood count, a comprehensive metabolic panel, biotin, parathyroid hormone, 125 dihydroxyvitamin D, uric acid, iron panel with serum transferrin, serum copper, and ceruloplasmin, and a 24-hour urine iodine. You could replace that with a serum iodine. And actually, I would measure 25 and 125 OHD, even though 25 OHD is on two of the big panels. I would also measure both of them from LabCorp request, just so that you can look at their balance when done by the same lab in the same sample. I have Testing Nutritional Status, the ultimate cheat sheet for interpretation. You can also book a consultation with me if you need help interpreting. Comprehensive screening for abnormalities in energy metabolism involves the following tests. Whole genome sequencing. I'm currently using DanteLabs.com, not necessarily because it's the best, but because it is currently yielding good results. The MitoSwab Plus test for respiratory chain function and differentiating the different complexes, the Great Plains Organic Acid test, and then from Quest, a plasma amino acids, serum and plasma, acetoacetate and beta hydroxybutyrate, lactate and pyruvate, carnitine and an acyl carnitine profile, acylglycines quantitatively in the urine, comprehensive metabolic panel, and non-esterified fatty acids or free fatty acids. I don't have a guide for interpreting these except a portion of this on the lactate to pyruvate and ketone ratios is covered in my article. All this is linked below in the description. And all of these things should be done with the necessary expert help and interpretation. You can book a consultation with me for that purpose. Not that it has to be me, but I can offer that. With a prepaid data analysis, I can also run your data files, your raw data files from the whole genome sequencing through MasterPass member Sergey Andryukin's app Gene Inspector, which allows me to search by metabolic pathway and cross-reference variants against multiple databases to help predict the variant's relevance to a person's metabolism. He hasn't commercialized the app yet, but is currently letting me use it for myself and my consulting clients. And I cross-reference the most suspicious genetic variants with the results of the testing that I had just described. I also think it's highly useful to monitor glucose, ketones, and lactate at home when optimizing energy metabolism. I use a Nova Biomedical Lactate Plus for finger prick lactate and a Keto Mojo for finger prick glucose and beta hydroxybutyrate. At minimum, these can be tested upon waking in the morning, correlated to the corresponding values in the blood work that I just described, and monitored in response to different strategies that are tried. And in my article on the lactate to pyruvate and ketone ratios, I go into more detail about how to use them, and I'll soon be sharing with you, by way of example, how I'm using them to optimize my own biotin and riboflavin balance. What's described above is a lot, but you can start with the low-hanging fruit before deciding whether you need to go further. I generally think of the basics of healthy diet, lifestyle, and stress management as the low-hanging fruit, and then climb up a little on the tree and you get to nutritional testing, climb up further on the tree to go into the idiosyncratic bottlenecks in energy metabolism. In other words, you probably shouldn't be thinking about whether you have a heterozygous fatty acid oxidation disorder that can be treated with riboflavin if you're eating junk food and you're sedentary and you never go outside. But if you're eating a healthy, well-balanced diet and you are active and you get outside and you practice good stress management and you're still hitting a wall, or you feel like, you've got to the point where you feel like you're getting nowhere, or you feel like, you're at 9, but you want to get to 9.99 and you've run out of things to do. I think that's the point where you climb up to the top of the tree and dig deep into the idiosyncratic bottlenecks in energy metabolism. My own experience is so far teaching me that energy metabolism is so universally applicable, that just built into the design of the universe and enshrined in the second law of thermodynamics, that optimizing idiosyncrasies of energy metabolism is often more fruitful than following condition-specific evidence-based medicine approach built on the behavior of group means in randomized controlled trials. For example, I just gave you how my response to dextrose powder and to biotin is different than the group means in randomized controlled trials. But it makes complete sense when it's looked in the context of how I am solving my own personal idiosyncratic bottlenecks in my energy metabolism. So have you found any surprise improvements in particularities of your health when doing something simple to improve your energy metabolism? If so, let me know in the comments. Please like, share, and subscribe, and check out the written version on Substack, link in the description for all the links. See you next time. Before you go, I just want to remind you one more time that I have a free gift for you. That is my MTHFR protocol, a 7-page quick guide to optimizing and personalizing your methylation status using foods and supplements. My MTHFR protocol is free to anyone who subscribes to my Substack, whether free or paid. Use chrismasterjohnphd.com/MTHFR or use the first link in the description. Enter your email, click subscribe, and you will immediately get a welcome email in your inbox that contains my MTHFR protocol as a downloadable PDF. I hope you enjoy your free gift and find it useful. Once again, that's chrismasterjohnphd.com/MTHFR. See you next time.